The year is 2025. Humanity stands at a crossroads, with technology and ambition reaching further than ever before. The world is watching, breath held, as the next chapter in space exploration is about to unfold. SpaceX stands on the brink of its greatest leap. Starship, the colossal spacecraft powered by the revolutionary Raptor 3 engines, towers over the Texas landscape, ready to make history. These engines are the heart of Elon Musk's interplanetary vision, more powerful, efficient, and reusable than anything before. Each Raptor 3 is a marvel of engineering, designed to fire again and again, carrying dreams as well as cargo. At Starbase Texas, the pressure is relentless. Teams work around the clock, pushing engineering to its limits. Every bolt, every wire, every calculation is checked and rechecked, as the world's brightest minds chase a future among the stars. The Raptor 3 is the key to making Mars a reality, enabling Starship to lift massive payloads and return again and again. With each successful test, hope grows that humanity's reach will soon extend to another planet. Early tests are promising: clean blue flames, thunderous roars, and hope. The night sky lights up with possibility, and the team celebrates each milestone knowing what's at stake. Then a whisper of trouble, a tiny anomaly in the data, a pressure reading just slightly off. It's almost imperceptible, but in rocketry, even the smallest detail can change everything. An engineer notices. At SpaceX, no detail is too small. Vigilance is a way of life, and every anomaly is a potential threat to the mission. The anomaly repeats, growing each time, a ghost in the machine. What began as a blip now demands attention, as the team scrambles to understand the cause. It's not a dramatic explosion, but a subtle flaw, a hidden weakness that could spell disaster. The margin for error is razor thin, and the consequences of failure are immense. The relentless march toward Starship's first orbital flight grinds to a halt. The launch pad, once alive with energy, now sits silent as engineers search for answers. The dream is suddenly in jeopardy. Tension fills the air, and the weight of expectation presses down on every member of the team. Every day of uncertainty is a day lost for the future of space travel. Time slips by, and with it, the momentum of progress slows. The world watches, waiting to see if SpaceX can overcome its greatest challenge yet. News outlets buzz with speculation, and millions hope for a breakthrough. The fate of the Martian dream hangs in the balance. The next steps will determine not just the future of a company, but the destiny of humanity's journey to the stars. To truly grasp the crisis facing the Martian dream, you must first understand the Raptor 3 engine, its promise, its complexity, and its critical role in humanity's boldest adventure. This engine burns super-chilled methane and oxygen, using a full-flow staged combustion cycle. It's an engineering marvel, pushing the boundaries of what's possible, but also a nightmare to perfect, with every detail demanding absolute precision. 33 Raptor engines power the massive Super Heavy booster, while 6 more are mounted on the Starship itself, forming the backbone of SpaceX's interplanetary ambitions. These engines must be not only powerful, but also reliable and endlessly reusable, capable of surviving countless launches and landings without fail. The Raptor 3 was designed to deliver a leap in both thrust and simplicity, a breakthrough that could make the dream of building cities on Mars a reality. SpaceX engineers pushed metallurgy and manufacturing to the very edge, inventing new high-performance alloys and pioneering 3D printing techniques to create intricate, robust engine parts. The result was a masterpiece of engineering, an engine that embodied years of relentless innovation and ambition. That's why the discovery of a flaw was so devastating. It wasn't just a technical setback, it struck at the very heart of the mission, threatening the dream itself. SpaceX's philosophy is rapid iteration: build, fly, fail, fix, and fly again, embracing failure as a path to progress. But this was supposed to be the mature final design. A flaw at this stage threatened the entire foundation of the Mars program, casting doubt on years of work. The very engine meant to carry humanity to Mars had suddenly become the obstacle, casting a shadow over the future of interplanetary exploration. The investigation was immediate and intense. Tiger teams dissected engines, scoured data, and searched for the invisible flaw. Externally, everything looked perfect. The problem was buried deep inside. After weeks, they found it: thermal acoustic resonance. High-frequency vibrations inside the combustion chamber matched the injector plate's resonant frequency. The plate vibrated like a drumhead, forming microscopic cracks, tiny time bombs. Under launch stress, these cracks could shatter the plate, causing catastrophic engine failure. The flaw was in the new high-performance design, not a single part. Every Raptor 3 was at risk. The entire inventory was compromised. The production line kept churning out engines with the same defect. A simple fix wouldn't do. They needed to re-engineer the engine's heart. The path forward was daunting, with months or years of work ahead. Starbase's energy turned to tension overnight. The gleaming Starship stood silent, grounded by a flaw measured in microns. The dream of an orbital flight slipped away, Delays threatened contracts, NASA's Artemis timeline, and SpaceX's lead in the industry. Investors grew nervous, the company's future was at stake. But the deeper threat was to SpaceX's identity, built on solving the impossible. Failure would fuel skeptics and shake the company's reputation. The pressure on engineers was immense, sleep vanished, meals were rushed, and every solution had to be perfect. A failed fix could mean disaster on the test stand. The countdown was no longer for launch, but for survival. The world watched to see if SpaceX could break through this wall. The company's fate and the future of Mars hung in the balance. The crisis demanded everything they had. When crisis hits, Elon Musk is in the thick of it, not as a distant CEO but as chief engineer. Musk flew to the McGregor test site, sleeping on a couch immersed in technical details. His presence amplified pressure but brought laser focus. He interrogated every assumption, led marathon meetings and forced radical thinking. Musk united experts from every field, breaking down silos and demanding first-principles solutions. His intensity was abrasive but essential. He set the bar impossibly high and worked alongside his team. Everyone knew this was the most important problem in the company. Musk wasn't just the boss, he was a fellow engineer, fighting for the future. With Musk driving the pace, the team launched a parallel assault on the problem. The sense of urgency was palpable, every hour counted, and every mind was focused on finding a solution. Multiple fixes were tested at once, new superalloys, redesigned injector geometries, and even unconventional ideas, all in a race to disrupt the deadly resonance that threatened their progress. The breakthrough came from a young team inspired by musical acoustics, acoustic baffles inside the combustion chamber. They realized that just as in music, controlling vibrations could be the key to harmony. These precisely shaped fins absorbed vibrations like dampeners on a drum, transforming chaotic energy into controlled power. It was a simple yet elegant solution. Advanced 3D printing made rapid iteration possible. Ideas became testable parts overnight, allowing the team to experiment and refine at a pace never before possible. The feedback loop between design, manufacturing and testing was SpaceX's superpower. Each test provided new data, fueling the next round of improvements. Modified engines were fired in relentless cycles, each test pushing the boundaries of what was possible and bringing them closer to a breakthrough. Finally, a hybrid design, stronger injector plate, optimized baffles, was tested. The team held their breath, knowing everything depended on this moment. The engine roared to life. Data was rock solid. The resonance was gone. The impossible had become reality. Relief swept the team. They had tamed the beast. Months of sleepless nights and relentless effort had finally paid off. The crisis had forced innovation at breakneck speed, forging a team that thrived under pressure and refused to give up. SpaceX's culture of relentless iteration had prevailed, proving that bold ideas and teamwork could overcome even the toughest challenges. The path to Mars was open again. The dream was alive, and the journey had only just begun. The fix was validated and rapidly integrated into production, setting a new benchmark for efficiency. Back-to-back tests confirmed the resonance problem was completely gone. Confidence returned, forged in the relentless fire of crisis. The new acoustic baffle design soon became a standard for high-performance engines. SpaceX emerged stronger, with deeper understanding and more refined processes. The Starship program roared back to life, full of renewed energy. In late 2025, Starship made its first successful orbital flight, a spectacular vindication for the team. The crisis became a war story, a lesson in humility and relentless innovation. SpaceX had reclaimed the future, keeping the path to Mars wide open. The heart of the Martian dream now beat stronger than ever before.